Welcome to Evolution Impossible, a production of 3ABN Australia Television. Our host is Dr. Sven Estring with special guest Dr. John Ashton and our panel.
Welcome to our Evolution Impossible journey. I'm Dr. Sven Estring, and you'll definitely need to fasten your seatbelts for this trip because we are going to be traveling way back in time to the very beginning, to the Big Bang itself. Sound like an explosive topic? Actually, you may be surprised to find out that the popular concept that the Big Bang was an explosion in space isn't what cosmologists actually teach. If that sounds intriguing, come with us on this journey. Joining me today is Dr. John Ashton, who's been doing research in this area for almost 50 years. Good to have you here with us again. And also Blair Lemke, good you could join us today.
Good to be here.
And Melvin Sandlin, it's always good to have you back on the studio as well. And Jean-Ray Roux, we're looking forward to your insightful questions. You know, John, as I was saying, the popular concept of the Big Bang being this explosion of matter into space isn't actually correct. So could you explain to us, what is the Big Bang Theory actually telling us?
Right, okay. Well, the Big Bang Theory is something that Fred Hoyle, the famous British astronomer at Cambridge Uni, felt was so ridiculous, that's why he called it, well, it's a Big Bang, is it? But
so it's a derogatory term?
Yes, originally meant, yes. But the whole concept of matter or energy expanding into space is too similar to what the Bible talks about, God creating and expanding the universe. And so cosmologists that really want to keep God out of the picture, they said, well, this is no good. We really don't want the Earth at the centre of the universe, because when we look out in space, it's sort of isotropic from where we are. It's almost as if we're in a spherical ball and we're near the centre of it.
So isotropic, explain that term
well, that
us.
means the density of matter is pretty well the same in all directions through the galaxy.
Wherever you look.
Yeah, so we look as if we're pretty close to being in the centre. And again, scientists who want to keep God out of the picture thought, well, this is too close to making the Earth pretty special. We seem to be in a very special place. We don't want that. So what they've done is they have contrived, in my view, what we know as the current Big Bang model, which is space expanding in a fourth dimension. And one of the reasons that they do that is that so that there's no centre to the universe then. And how this occurs is this. If we imagine blowing up a balloon, right? So you've got a balloon. Yeah, so just a party balloon, right? Okay. So you start your balloons about this size. Now, when we've got our balloon and we've blown it up to about this size, we then take a texture, a little pen, and we draw little circles over it, okay? So if we're going to make little polka dots.
And what do the circles represent?
They just represent little circles.
Okay. Fair enough, fair enough.
So we'll just draw these little circles around, just like a polka dot pattern on this, okay? And so we've got those little circles, and now we blow it again, and it expands, okay? So as it expands, those little circles move further apart from one another, right? And so we've now got our bigger balloon. And
it hasn't gone pop yet?
No, it hasn't gone pop yet. No, it's not going to go bang either. This is the stabilised, this is our current situation, right? This is the expanded Big Bang, in a way. But we've got this balloon, and I want to ask you then, where's the centre of the surface of the balloon?
It doesn't have a centre.
It doesn't have a centre. Now, what we have observed, when I was blowing this balloon up, as you had to imagine, what we were doing was, with that surface of the balloon, that skin of the balloon is a two-dimensional surface, but it was expanding in 3 dimensions. Right? And there's no centre to that. So if we have space, which is 3 dimensions, expanding in 4 dimensions, again, there's no centre. No, just 4th dimension.
Yep.
Yes, not necessarily. It doesn't have to be time. Time is outside that. They're just expanding in a 4th dimension. It's just a mathematical construct. involving what they call hyperspace, this theoretical fourth dimension. Now, they have to do that. When they do that, then there's no centre of the universe, and it explains why the universe looks much the same wherever we look, right? Because we're on the surface of this sphere. So cool. But while I'm using the sphere is just because we can't in our minds imagine a fourth dimension. We can't physically, easily anyway, some people might, and be able to imagine 3 dimensions expanding in fourth dimensions. But we can do it mathematically. It's very easy with mathematics, as you probably know with your maths background. But this is called the cosmological principle, or the Copernican principle, and that is a construct to deliberately keep out the obvious observation that we seem to be very special at the centre of the universe. But it relies on hyperspace. It relies on the existence of this fourth dimension, which has never been detected, and we have no evidence for it. It's just a mathematical construct.
So it's the expansion of space itself.
Yes.
And not just this explosion of matter into space.
Yes.
Okay.
And there's a number of reasons that I want to do this too, because you see what happens is when they believe part of the evidence for that they claim is for the Big Bang is what we call the cosmic microwave background radiation, which is this infrared or microwave radiation
that you can observe.
Infrared, microwave radiation, which they say is the leftover from the Big Bang, and we observed this background radiation there. Now the problem is there's a horizon problem for them that they have.
And
May
this first ask what that is?
Right, the horizon problem is this, that you can't see anything happening faster than the speed of light.
So there's a horizon to what we can
so
see.
there's a horizon for energy and so forth to travel, as far as they understand.
Is that the cosmic microwave background radiation?
No, what it is this, that if that is what they say this microwave background radiation is, it's the leftover remnant radiation from the massive Big Bang in the beginning. So it's what's been left over. But the fact that it's so uniform means that it has to have spread uniformly across the universe.
Yes.
Right. But if the universe has been expanding to the size that it is in the time that it has, even if this microwave radiation was travelling at the speed of light, there's not enough time for it to distribute itself uniformly. So they have their own problems, right? But if you have space expanding in the fourth dimension and you have it all close together, then you can have this distribution occurring while it's all close together, and then space is stretched out, and so it isn't limited by your sort of luminary constraints of the speed of light. So these are all fancy mathematical constructs, and you run into other major problems like where did the energy come from to expand it like that so quickly? It has to happen, so quickly. Yes. So there's so many problems with the Big Bang.
So tell us. So you've got the cosmic microwave background radiation you mentioned. What is there any other evidence for the Big Bang in terms of that cosmologists would use to support this theory?
Well, of course, they date the ages of they detect particular elements in the stars, and from the radioactive elements that they detect there, they, calculate the ages of, 14 billion years and so forth. So they make these sort of estimates. But look, the bottom line is there's so many problems with the Big Bang, but this just isn't being talked about. We can have a look at some. For example, if this cosmic microwave background radiation that they detect was where we would expect shadows behind certain nebulae and so forth like this. We don't observe any shadows. They've studied a whole lot of these particular behind galaxies. They've observed a whole lot of galaxies, over 30 I think, and none of them we observed any shadows behind. So that's powerful evidence that the Big Bang actually didn't occur. That's really powerful evidence.
What about the redshift in galaxies and stars that they've detected?
Well, these are used to calculate, the speeds of stars and movements and things like that. I think one of the things that, from the Doppler effect, and again, it's just all physics, but one of the things that, again, they've got so many major problems in that, for example, that they have to have inflation theory in that there's no known laws of physics that can explain how this singularity, and all they mean by, they talk about a singularity exploding. What this singularity is, well, there's all different views on it. An infinitely mass, infinite heat, infinite energy sort of something at the beginning.
Sounds pretty hot.
Suddenly expanded, yes. Well, that's the hot Big Bang model. There are cold Big Bang models too. There's lots of different Big Bang models. But the thing is, in order to it to work, if we apply the standard laws of physics, it doesn't work. So
physics breaks down.
Yeah, physics breaks down there. Yeah. So you just have this whole game of mathematics there, which is really fun, and you can be creative in mathematics. But what the bottom line is, they have to have what they call inflation theory, which is the laws of physics were very different back then. And yet they criticise us for believing in creation. They say, well, you can't test creation, therefore you can't, it's not a scientific testable theory, therefore you can't teach it in school. But we're going to teach Big Bang with inflation theory. Hang on, you can't test inflation theory? I mean, this is just so wrong,
That's interesting. That was what I had a question about, because that really struck me as I read your book, that you wrote that one of the things that would be necessary for the Big Bang to work is that inflation theory. Well, at the same time, this cosmic microwave background radiation that is cited as one of the biggest evidences for that the Big Bang happened, but it would need that inflation theory, which has never been tested or observed or seen, and it is even defying the laws of physics as we know it. How can this then be used as one of the biggest evidences when it's based on a big assumption?
Yeah. Yes, and the thing is that the average person doesn't realise this, but the reason why scientists continue to work in this area is it's really the only theory they've got. They have string theories, and people are coming up with all different types of theories at the present time. But it's the model that most people are playing with, because the other models have big problems as well.
Right.
But what gets me is that if we just simply look at it, the cosmic microwave background radiation levels are simply what we would calculate from that generated by starlight. It just fits what we observed. There's a very simple explanation for it.
Interesting.
One of the other fascinating things is that we have a law in physics called the law of Bayron Number. And what that says is that if we convert energy into matter, we produce equal amounts of matter and antimatter. So most of us have seen the equation E equals mass times the speed of light squared. Right, equals mc squared. And so we can convert energy into matter. But when we do that, we generate both. So, for example, the antimatter to an electron would be a positron, right? Now, when we look out in space, we observe something like 95% matter. We don't observe a 50-50 balance of matter and antimatter. There's only about 5% antimatter out in space.
How does that relate to dark matter and dark energy?
So this is where it comes in. They have dark matter is there to provide the balance in that equation. But also the other problem that they have is this, that when you convert energy into matter, you produce individual atoms and nuclei, and these have to come together, right, in some way. Now, the simplest ones, hydrogen, helium, they're gases, right? And they just stay apart. So you've got to somehow, to synthesise the higher elements, you've got to somehow produce super intense gravitational fields. So you've got to somehow get these gaseous elements together again. They're not going to come together. And so in order to get them to come together to synthesise the higher elements, they say, well, there must be dark matter that produces this intense gravitational field that pulls all the gases together so that they can condense and begin to fuse and produce the higher elements.
It sounds so scientific. It must be. It must be.
The problem is we've never detected that either, And these are all these constructs that they have made up to try and save the Big Bang Theory. Dark matter, dark energy is again where this energy came from to sort of just expand the universe fast enough.
The inflationary period.
Yeah.
Interesting.
All these things, and without them they fail. And one of the things that people don't realise, or many, scientists working in the field realise this, but all the attempted experimental, all the predictions that would fall out of the Big Bang Theory when they've attempted to test them experimentally have failed. They don't. It doesn't predict the right number of sort of evolving galaxies and all this sort of thing. And that was this has been known for some time now. Matter of fact, in the early 2000s, about 100 or 200 scientists signed a statement that was published in New Scientist saying, look, there's so many problems with the Big Bang Theory, we really should stop teaching it.
Wow.
And you had people like Halton Harp, who was the chief astronomer at Max Planck Institute in Germany. You had Thomas Gold at Cornell University. Had these top university professors saying this. Hang on. It's not working. It doesn't work. It doesn't fit the scenario. The biblical picture fits what we observe out there, that the Earth is special, we're near the centre of the universe, and it was made as the environment around us.
Dr. John, I was curious, you talked a little bit earlier on about, the inflation theory, dark matter, dark energy, these sorts of things, these hypothetical entities that cosmologists have, I guess, created to try to make the Big Bang Theory seem plausible. I guess I'm wondering, is this a common practice in the scientific world to kind of create hypothetical entities to try to explain things? Is that something that holds water in the scientific world? Obviously it does in the Big Bang Theory here, but it just doesn't seem very...
Well, scientific hypothesis, yes, this is a common approach.
Yeah.
That people use. And the idea is, okay, we want to see how this system works, we propose a hypothesis, then we design some experiments to test that hypothesis and we see if they work. If that doesn't work, then usually we try to change the hypothesis or throw it away altogether.
Reject some of those hypothetical...
And so the Big Bang Theory is something that people have been working on for a real long period of time. They've been build these very large high energy colliders to try and understand what happens in the nucleus of an atom under really extreme conditions. How can we try and model what sort of conditions were there at the Big Bang? But essentially, the Big Bang model is saying that nothing somehow became something,
That's
and you hear quantum, fluctuation in a vacuum and this sort of thing. Well, it's not really a true nothing that they're talking about when they're doing their equations there. It's sort of a quantum vacuum.
Lawrence Krauss, with his book A Universe from Nothing, actually equivocates on that word nothing. He's not talking about nothing. He's talking about something.
That's what I have a question about. That maybe risking to sound like a dummy, because maybe there's explanations for it that I don't understand or haven't heard. But for me, like the Big Bang Theory, that even if all of that would have happened and everything worked as they said, that still does not explain where the first things came from, right? Because for a Big Bang to occur, you need something that makes a Big Bang. Yeah. And that is something that I've never understood, that where then does that come from? Yeah. And the Bible does give us a picture where everything came from. It came from God.
Yes.
So that, to me...
So what you're saying, Melvin, is that it really defies the logic of cause and effect.
Yeah.
So you get this effect, a universe, but there's no cause for it.
Exactly.
Yeah, so there's a philosophical argument that essentially goes along the lines that if something has a beginning, it must have had a cause. And it's fascinated me that the Bible, when God describes himself as God, he talks about himself being the self-existent one. In other words, I don't have a cause. I have always been. And this is a fascinating concept, because the fact that we are here is evidence that, is evidence that something has happened. And I know I've spoken to other people, and we've asked ourselves the question, why should anything exist?
It's a very
when
deep
we look
question.
around, but it is, and it's so intricate. We saw the pictures earlier of the hummingbird. It's so phenomenal, and giraffe, and the amazing creatures there. But even a tree, when you think, that tree has to get that water all the way up. The amazing mechanism and design to be able to do that without having some high pressure electric pump.
Yes.
Against every 15 feet, every 34 feet, you've got an atmosphere of water sort of thing, atmosphere pressure that you've got to overcome. Why should anything exist? Why does it exist? But it does. Where did it come from? It blows your mind. And that's where God fits the picture perfectly. And it amazes me, people say, and because people say, well, who created God? Well, you're going to run out of problems because the issue is we are here. But God, in this book that so many people put down as, it's just myth, here we have God saying, I am non-material and I am self-existent. And this is brilliant. It explains everything, really. And it is an explanation that works.
All these assumptions just make me think of like Hollywood movies.
Yeah.
Like, it's just far from reality.
Yeah.
But yet people still choose to believe the Big Bang,
I mean, talking about movies, even Maria in Sound of Music knew that nothing comes from nothing. Nothing ever could. It's an amazing insight. But bringing you down from this stratospheric kind of talk about the universe down to Earth, one of the things that comes out in science is that the Earth is in a Goldilocks zone. And I was just wondering if you could explain that to us. Obviously, it's not just the story about Goldilocks with the porridge and this nice warm bed. What's that to do with the Earth, the Goldilocks zone?
Yes, okay. So there have been some authors that refer to the position of the Earth in it is very special. And when you think about it, we're at just the right distance from the sun, so we don't cook and we don't freeze. Our gravity is just right, that hydrogen escapes and doesn't poison the atmosphere because water does solidly dissociate into hydrogen and oxygen, a small amount. There's equilibrium constant there. So we don't get poisoned by that sort of thing. The moon is in just the right place to cause the tides and this sort of thing. This is another evidence for a young Earth too. I mean, the origin of the moon. So the astronomers have really no satisfactory explanation. They've studied the composition now, especially based on titanium, for example. One of the most abundant metals in the Earth's crust, and it's the same level in the moon. And of course, the moon is dragging against the Earth, so it's actually slowing the rotation of the Earth down very slightly. And as a result, it's absorbing that angular momentum and moving slightly further away. And so again, if the moon was, thousands of millions of years, if the Earth was thousands of millions of years old, it's impossible. The moon would have crashed in, wouldn't have been here. So it just doesn't fit. The ages, there's so many things like that as well. But when, again, we look just the right temperature for water, our atmosphere is just right, and we have so much water on this planet. Yeah.
So these are powerful reasons why you believe that the Earth is young. But you also believe that the entire universe is young as well. What leads you to that conclusion when there's all this evidence or supposed evidence for billions of years for the universe itself?
Yeah, sure. One of the reasons that I think about is that when I look and I read the astronomy books, I read so much research about things that are happening on our timescale. It's almost as if we're meant to be watching it. And of course, the Bible describes that. And so how can we know the age of things? And I was reading a paper just the other day by some Japanese astronomer first observed this particular white dwarf expanding. And the thing is, this star exploded, changed, exploded, and then shrunk right back down. So it went through a lifetime cycle in about 5 years. 5 years our time, Wow. And I know people get worried about the starlight time problem, and we did talk about the other day.
So that's how can you get starlight from stars or galaxies which are billions of light years away? But we could actually see it if the universe is young.
So what we need to remember is that the light year is a measure of distance. It's a measure of how far light would travel if we average the speed of light. But as we discussed in one of the other programs, we can't actually measure accurately and know accurately the one-way speed of light. And it seems to me to fit, and it fits a lot of data, if the one-way speed of light is infinite, if it's instantaneous, and therefore the return signaling. Now, people say, oh, you know, you're wishful thinking there. Well, it fits mathematically. It's quite allowable. It doesn't violate any of the laws of physics, because the value of c that we use is the average of the two-way speed of light. That's the value that we use. We just use the average of the two-way speed of light. And the other factors are, when we think about in terms of time, why would God want us to be looking at things in the past? You know, it makes so much sense that we are able to see things, you know, here and now. And also we have the time dilation problem, the whole problem that time is affected by gravity, as we've talked about before as well. And so we're measuring things in terms of Earth time now. You know, this is very important to understand, that we're measuring things in Earth time, and those, you know, big distances for light travel there may not in actual fact be a problem. The evidence, in my view, is that the universe is very young.
And George Ellis said that you can actually create any cosmological model you like. It's just depends on the philosophical assumptions that you're making.
Yes, that's
so
right. Yeah.
Could you just maybe quickly explain what he meant there?
Well, again, what essentially what he's saying is that most of the current models that are being developed are models to try and eliminate God. And they're based on that particular worldview. And so, for example, John Wheeler got his PhD back in the early 50s on the multiverse. You know, that there are millions of universes, that there are different space-time systems outside. One of the other things, just to mention very quickly, is that quantum mechanics predicts instantaneous interactions at a distance faster than the speed of light. There are lots of interactions faster than the speed of light.
And we'll have to pick that up another time. So the Big Bang is based on massive assumptions and has been patched up with so many fudge factors. It makes me feel that the Big Bang is a cosmological model that needs to be traded in for a better model. And you can find the best model, the best explanation in the Bible itself. This timeless bestseller starts with those majestic words, "In the beginning, God created the heavens and the earth." Now, that's something you can really trust. If you want to discover why the Big Bang Theory fizzles, just go to your favourite online bookstore and get a copy of Dr. John Ashton's book, Evolution Impossible. You won't regret that small investment. Did you know that Dr. John Ashton is not the only scientist who has rejected Darwin's theory of evolution? There are literally hundreds, even thousands of scientists who've decided that the Bible is telling us the truth. Join us next time as we introduce some of those scientists and the powerful reasons why they reject evolution.
Thank you for joining us on Evolution Impossible, a production of 3ABN Australia Television. If you have any comments or questions, send an email to radio@3abnaustralia.org.au or call us within Australia on 02 4973 3456. We'd love to hear from you.